So I think you must have come across the geospatial analysis lecture, I think a couple of weeks back. And let's just try to do some live coding and see if we come up with any issues here and discuss and try to solve those issues so that you might be much more familiarized with how to do geospatial analysis. And the discussion is actually helpful. It will help you solve problems if any other problems come down the line for you. So I think first, for any code that we need, any coding type of analysis, first you'll have to begin that with your modules, your libraries. And does anyone remember which libraries we actually use for geospatial analysis?
There was a class Nominate, I think.
Nominatum, no, I don't think, but that is useful, definitely useful if we want to, if we want to get this latitude, longitude. Any other thing that was required?
GeoPy?
GeoPy, great, that's great. GeoPy. So we needed GeoPy. And what are the other libraries that are usually required, that's usually important when we try to code? Any very popular libraries that we use for any Python coding?
Pandas.
Great. What is Pandas for? Any ideas?
Reading the CSV file.
Okay, and is that the only reason why?
For data analysis.
Okay. Can you be more specific? That's right, but can we drill down a little bit?
Data frames.
Great.
Data frames.
Yeah, data frames. That's right. So in Python, you definitely come across lots of data frames. Data frames are nothing but tables. So if you need to do any manipulations on the data on the tables, then you definitely need pandas. So primarily pandas is used for that. Then we also require NumPy, but I don't think we'll be needing that here. I'll just use it anyway. Then as you all mentioned, we need GeoPy. That was used to compute the distance. And finally, we also needed another library for actually, for displaying maps, for visualizing maps. Does anyone remember what that was? Which library we used to display maps, to visualize maps? Any guesses? Okay, I think, do you remember something called the Folium? We use something called Folium, and this library is actually helpful for you to visualize maps. So once we import these things, it's just the usual, just run it. And then our data is here in this location. We just read that using the pandas read CSV, and let's see what is there in this data. So what is the common command to see the first 5 rows or the last 5 rows? Head. Great. If it's the last 5 rows, we use tail.
Tail.
Yeah, that's great. So you see that? So we have the latitude, longitude, and we have different stores. So these are actually the list of stores. You have different types of coffee, your snack stores, your coffee stores called Starbucks, and there's also the McDonald's, fast food. These are the fast food chains. So this data has a list of fast food chains in New York. It has the latitude and longitude. And our goal here is to do some geospatial analysis on this data. So why would we actually use geospatial analysis? Any ideas? Why is that really important, geospatial analysis? In this case, suppose in this case, we have this data, right? We have latitude, longitude, we have different stores, fast food chains, and then we have this addresses. So why would actually we need to do some geospatial analysis with this data? Any thoughts on that?
To correct a perfect location address.
To perfect the location address, could you please try to be more clear on that? What are we trying to do here? In general, so if you're trying to do any kind of analysis, you have this data, you have data about different stores, you have different addresses, you have latitude, longitude. And what type of analysis would you do? Why would we actually do some type of analysis with this data? what business ideas might we be having that we would want to do this kind of an analysis.
Sir, to get the number of coffee shop in the nearby.
Okay. So that is okay. That is very good. You're getting at one level of understanding. Something higher than that. What is the next level of understanding? Okay, we want to know how many shops are here, but why would we want to know how many shops are here?
To improve the coverage.
To improve the coverage. Yeah, that's a very good point. Any other points?
If someone wants to start a new coffee shop, then this might be
Great.
helpful.
Great. That's a very good point. So as I think another someone mentioned here that to get to know the coverage of our coffee shop. So if you already have some many coffee shops, and if you're trying to also open a new branch in the particular given area, we might want to do this kind of analysis. So this will tell us how many coffee shops are there. If already we have so many shops in a particular location, that it's not a good idea to go and start a new shop there. So that is one of the reason why we would want to do a geospatial analysis to understand how the different stores are located in the particular geographic area. To basically to understand what is happening in a given geographic area, we try to do geospatial analysis. So now that we have this data, what we can do next? So let's actually try to visualize all these stores. So we can use this Folium library and try to visualize this data on the Google Maps. So for that, we can use the Folium library dot map, and this requires some parameters. One is the location. We need to give some value here. This is something called a start location. So start location is where your map will actually begin. If you run this code, it will start at a center point. So we need to give some kind of a center point here. And here, since we know all the data is from New York, so we might have to look for a center point that is in this New York area, New York district and New York City. So we have, I think in the example that we used in the lecture, we used the Empire State Building. So if we go to the Empire State Building, so you see here, we can already see lots of cafes here. And I think we are particularly looking at the McDonald's and Starbucks. So we need to get the latitude and longitude. Let's just right click. You have the lat coordinates here. Just copy it. And then you can use this. This is the Empire State Building coordinates. We have that here. So now in this Folium map, we need to give a start location. We can use this Empire State Building coordinate at the start location. It also requires another parameter called zoom start, which tells you how much you need to zoom in. So the larger the number of the larger the number here, the more zoomed in will the map be. If I give 20, you'll actually have it a very close. It will be very zoomed in. If you give a value 7 or 6, the lesser the number, it will actually be zoomed out. So once we give this value, let's just run and see what happens. There you go. You have this map, and you see this is the New York map. And this map is, since we gave the location start location as Empire State Building, this map is centered around Empire State Building. So Empire State Building must be somewhere around here in the center. So that is why we gave this location in this parameter. So now what we can do is, now that we have this map, let's try to visualize all these stores in this given area. So let's start off with doing that. But for that, as you require, we need some coordinates. Just like we have coordinates for Empire State Building, we might want to create some coordinates for each and every store. So let's create the coordinates for that. Let's create a coordinate and add it in this data frame. So we already have a data frame called df, which has the data. Let's add a new column to this data frame. How do you add a column? You just give df and coordinates, and you give you're trying to create a concatenated column. For that, you'll have to give this plus df dot. We are trying to concatenate the latitude and longitude value so that we can get a combined string plus and df dot longitude and some closing braces. So let's run this and see if a new column has been created. No, okay, you don't need a dot here. Dot is not required. Okay. So we have an error. It says that it's a float error. Any ideas why we are having this issue? Anyone here?
Coordinates are float type, but we are trying to do it in string.
Great. That's right. So
Can we just print directly by comma?
Comma, it's just to give it, a coordinate is one latitude, comma longitude. You can do that. That's it. It's just to give it a uniformity. That's why we're using a comma there. It doesn't matter though. So to convert this to a string, you use this as type. It's a common function that we have. And now I think if we run, it will work. Yeah. So now we have these coordinates, which gives you the latitude and longitude of each and every store. Now that we have these coordinates, we can actually use again this Folium library to place markers on this map. So we have the map. Now we need to place markers in different locations. So again, we can use this library to create markers. So for row and there's something called interrows. This function actually goes through each and every row. So I think it's showing an error here. We need to mention which data frame we are trying to read. So it's df, not it is iter rows here. So you need to go through each and every row of this data frame. That's what we're trying to do. Iter rows does that. I will store the index values. Row will go through each and every, we will have the values of each and every row. So what we're trying to do is we're trying to go through each and every row and get this latitude, longitude values. Once we get that, we can place a marker on this map. So latitude value is nothing but I, we get the lat, but we are reading this from this data frame. So df dot loc, which will get us the given latitude value. Then longitude values again df dot loc, and in this data frame it is this lng. So that value. Let's get also the store values. Store. Now that we have these values, so there are two types of stores here. If you see, in the data we have Starbucks and McDonald's, two types of stores. So we'll give a different color to each of these stores. So if the store is equal to Starbucks, we'll give it a color green, and else we give it a color red. And then finally we use this Folium marker So it takes many parameters, as you see here. It takes a parameter called location, which is the lat and long values that we created now, longitude values, and then pop-up. This is nothing but the pop-up that which mentions what type of store it is. Is it a Starbucks or is it a McDonald's? So this is nothing but equal to the store value that we created here, this variable store. And finally, we can use an icon. This is just a default icon that Folium uses. Icon. And this icon needs to take different colors based on what store it is. So we give color is equal to color. It takes on either green or red values. And now that we have created these markers, these are just markers. So these markers need to be added on this map. So to add that, you use this function called add to. And you need to add this to a map object, but we haven't created the map object yet. So let's go to the top line here and create, this is the map object. And once we add this markers to the map object, I think it must work now. Let's just print it out and see. Okay, so there you have, if it is green color, it is Starbucks. If it is red, it is McDonald's. We mentioned pop-ups and all here, so it must show what the names are. Just scroll in, zoom in, and just click it. Yeah, this is Starbucks, this is McDonald's. And so from here itself, you can get an idea. So you see that there is, I think, okay, let's see what actually you can see here. Can you give me some ideas on what we actually observe here? If you're trying to set up a store or open up a store, in general, based on the visualization of McDonald's and Starbucks markers here, what do we observe?
Less number of Starbucks store.
Yeah, there are.
Less number of Starbucks store.
The green ones are the Starbucks stores, is it? Yeah. Are the green ones lesser or are the red ones less?
Seems to be red one lesser.
Yeah. So there are more number of Starbucks stores, right?
Yes, sir.
Yeah. So you can see that there are so many Starbucks stores, and also if you see that these Starbucks stores are actually concentrated more in this area. And if you see the McDonald's store concentration is a little higher on this area. So we might come up with different theories of why McDonald's started here or different Starbucks here. So these are different reasons of why you might do a geospatial analysis. This actually gives you some insights as to what made McDonald's start their stores here or what made Starbucks start their stores here. And why is it that we have so many Starbucks stores here? So there has to be some reasons. So this kind of analysis can be done later on. So that is why we use geospatial analysis. It gives us some basic insights as to what kind of answers can be, what kind of answers we can come up with once we have some kind of a research problem in our mind. So this is just from the visualization. On top of that, we can also see how distant these stores are from each other, or how distant these stores are from a center point. So we chose Empire State Building as a center point. So let's use that to calculate the distance of each and every store, the Starbucks and the McDonald's store, from this center point called the Empire State Building. So to calculate distance, I think we already imported this function called GeoPy. This GeoPy helps us compute distance. So let's try to compute the distance now. Let's create an empty list because we'll be using this list to store the distance values. And for row and iter tuples, this is another function that will help you go through each and every rows, just like the iter rows. But here, actually, iter tuples is much faster than iter rows. But iter rows enables you to even get the index values separately here. You can get the index values and each and every row. and IIT tuples doesn't have that, but still IIT tuples does the same has the same functionality, but it is actually much faster than IIT rows. If you're having a dilemma between using IIT tuples or IIT rows, it's better to go with IIT tuples. So let's compute the distance. So distance, okay, let's use the GeoPy function, GeoPy distance. And so if you have some doubts on what type of distance do we use here, you can just look for compute distance using GeoPy. We're trying to calculate the distance between Empire State Building and every other Starbucks store. So it's a distance between 2 points that we are trying to compute. And so you see, we can calculate the distance using either geodesic distance, which actually calculates the shortest path between 2 points on any surface, or we can use the great circle distance. It calculates the shortest path between 2 points on a sphere. So geodesic distance is more appropriate. So how do we just need to use geodesic and call the two cities, 2 points, point A and point B. Geodesic. Let's use, first point is the Empire State Building, and then the distance of this with every other coordinate. This row value will actually store each and every row of this data frame. So again, I think I missed it here. You need to mention df dot itertuples. So,
hello, sir.
Yeah.
Yeah, one doubt. So why is this geodesic more suited than geo, like the great circle?
Yeah. So great circle is 0.2 points on a sphere. So in general, Earth is said to be spherical, but it is actually not spherical, right? It's more oblong. I think it is flattened at the poles and more widened in the equator.
Right.
Yeah, so I think geodesic should actually give you a much more better value. So in general, if you're trying to find the distance between 2 points on an Earth, people go for geodesic distance.
Okay, so geodesic something which computes distance on any surface.
Yeah, on any surface. Yeah, that's right.
That makes sense. Thanks.
So geodesic takes two values, point A and point B. So this row stores the coordinate values. You mentioned row dot coordinate. This coordinate value comes from this data frame. So you have coordinates right here. The IIT tuples will go through each and every row. Row 1, it'll take row 2, it'll take row 3. So if you write row dot coordinate, it will take up this particular value from this column. So that's what we're doing here. From row dot coordinate, we're doing that. And this will get you the distance. So now we can add this distance. We have created a distance, but we need to add this distance to this variable that we created. We have an empty list variable. Let's add the distance to that. Distance dot append. And so just like we created a coordinates column. So we already created a coordinates column earlier. Now let's create a distance column that gives us the distance for each and every store from the Empire State Building. So we just create a column called distance that is equal to. So let's try to run it. Okay. Coordinate spelling. Okay. So it says there is no attribute called coordinate because we stored the variable name as coordinates. Okay, so now we have the distance for each and every store from the Empire State Building. And if we see that we have here, I think this has come up as an object, but it's better to have distance in terms of float. So for example, if we use this dataframe.info, it will tell you what type of variable it is, what type it is. If you see here, distance isn't type object, but we need this as a float. So this has an inbuilt function. By just adding km here, .km, it will give you the values in kilometers. Now you see that, I think if we check again, we'll see df.info, just check here. And you'll see that distance is now in a float type. So that is great. Now we have the distance. So now if we can just try to do any type of analysis. If you're trying to see how many stores, Starbucks and McDonald's stores are within a given radius. Distance. So how many stores are maybe at a distance greater than 10 kilometers? Just run it. So now you'll see there are around 1, 2, 3, 4, 5, around 9 stores that are at distance greater than 10 kilometers and a radius of 10 kilometers from the Empire State Building. These are the Starbucks and McDonald's stores. And you might also want to do some kind of an analysis like which store is at the farthest? Is it the McDonald's store the farthest or the Starbucks store the farthest? Which is at the most farthest distance? You can also compute that. So you can use something called the aggregate function. df.aggregate. You want to aggregate the distance. So for example, you might want to find the average distance of the stores and the maximum distance of the stores or the minimum distance. If you just run it, it will give you, but this is not giving you for different stores. If you want it for different stores, do you have any idea how do we get the values for different stores? Any suggestions? We were able to get the mean, max, and minimum distance for all the stores together, but if we want it for separate stores?
Maybe, sir, first of all, filter the data frame.
Okay. Any other simple way? Any other ideas? Have you heard of this function called group by? So you can use this group by function. Group by, you want to group these things by the store. And then if you compute this, there you go. So here it gives you for each and every store. So we have 2 stores, McDonald's and Starbucks, and it gives you the mean distance. So on an average, the McDonald's stores are actually at a greater distance than Starbucks stores. So as you could see in the map above, the McDonald's stores are on an average a little bit farther from the center. This actually tells you, it can give you some insights on maybe the McDonald's team, sales team is doing some kind of analysis on the revenue, and they see there is some kind of a revenue dip a particular year, and the management asks different reasons of why, what is happening. And then you might actually do this type of geospatial analysis and see, okay, maybe the stores are located far away from the financial center. For example, if the financial center of New York is somewhere here, and if the stores are located far away, people will tend to go to the stores that are nearby. So it actually makes sense to open up more McDonald's stores in the city center than opening up stores in far away. So this kind of analysis helps you give different insights. So for example, from this itself, we saw that McDonald's stores are located far away. And even in terms of the maximum distance, you see the McDonald's stores are located the furthest. This is about 14 kilometers far away. This is 13.9 kilometers. Not that much of a difference, but still, you can see that the McDonald's is a little bit spread out, has lesser number of stores, and it is located in a farther distance when compared to Starbucks. So these kind of analysis can be done using geospatial analysis, and it is very helpful for you. It can serve for either as an exploratory analysis. For example, you want to derive different insights. You can explore, you can come up with different research problems by doing geospatial analysis. Or if you have a problem in mind, a particular problem, that why is your revenue falling or why is your sales falling, you can also use geospatial analysis to answer a particular problem. So if you have a problem in mind, you can use this to find insights about that, or you can do some kind of an exploratory research and come up with different insights from geospatial analysis. So I think this was a similar thing was done in the lecture. This is just a repetition of that so that we could have a discussion here. So if you have any doubts, you can ask me doubts on that. We'll try to clarify. Was the thing clear to you?
Yes, sir.
Okay, that's great. So I think if there are no questions on this, let's see if we have any questions on project, or if we have any questions on it, on the ROE. Any questions on that?
Sir, if you could go a little bit up in this
Okay.
collab.
Okay. Yeah, this is the top.
No, sir, down, sir, please
Down.
down.
Okay. Yeah.
Sir, here. So here, we have iteration here, for loop.
Yeah.
I comma row.
Yeah.
So latitude equal to, you have used LOC, right?
Yeah.
So instead of LOC, can I write simply row dot lat?
Row dot lat. Will that work if it gets the value? Let's check. Yeah, that too works. That's right.
Okay, sir. Okay.
You ultimately just want the value there, right? That also works. Yeah.
Okay, sir. Thank you.